Hello, I'm Carlos Rosasaurus and this is the CRS channel. This video gonna finish up the geometry problem we've been working on for the last videos. For a circle circumscribed to a triangle, the product of the lengths of any two of the sides of the triangle is equal to the product of the diameter of the circle and the altitude traced to the third side. Okay. Let's summarize then again the formulas to obtain. We're going to work with the formulas for the sines of the angles alpha and beta. So we have that sine of alpha equals HB over C. If we look at right angle triangle BEA, and is also equal to HC over B for right angle triangle AGF or AFG. Okay, so that leaves, it gives us HB over C and HC over B. Sine of alpha equals HB over C and HC over B. Let's see if we have that written over here. Sine of alpha equals HC over B equals HB over C. Okay. Sine of beta equals HA over C for right angle triangle BDA, and is also equal to HC over A for right angle triangle BGF, which is we have BGF here and we have BDA here. Just that BDA. So those are the same, but the triangles are analogous. So then let's remember that HA over C equals HC over A. HA over C equals HC over A. Remember that A is cathetus BG. So HC over A equals HA over C. Here we have HC over A. HC over A equals HA over C. And again, sine of theta 1, looking at right angle triangle BGG prime, sine of theta 1 equals A, that is cathetus BG over the hypotenuse, which is the diameter of the circle GG prime. So sine of theta 1 equals A over D. Sine of theta 1 equals A over D. And looking at right angle triangle AGG prime, sine of theta 2 equals cathetus A over AG, which is B, over diameter GG prime, which is D. So sine of theta 2 equals B over D. Sine of theta 2 equals B over D. Okay. Looking at a right angle triangle BGG prime, we have that G1 plus theta 1 plus right angle GBG prime equals pi. That means that theta 1 and gamma 1 are complementary, and then gamma 1 equals pi halves minus theta 1. And the same we can say for gamma 2 and gamma 2 and theta 2. Gamma 2 equals pi halves minus theta 2, and we know that gamma 1 plus gamma 2 equals gamma, gamma 1 plus gamma 2 equals gamma. We know that looking at triangle BGA, that alpha plus beta plus gamma equals pi, and then we have that alpha plus beta plus pi halves minus theta 1 plus pi halves minus theta 2 equals pi. That means that alpha plus beta minus gamma 1 minus gamma 2 equals 0, which gives us that alpha plus beta equals theta 1 plus theta 2, this relation here. Okay, now looking at triangle BAC, we have that beta plus theta 1 plus this delta, that is angle ABC, equals pi halves, and we also have that alpha plus this delta plus theta 2 is also equal to pi halves. Remember, y is this theta 1, this theta 2, y is this delta, and y is this delta. Remember, triangle BAC is an isosceles triangle because segments BC and CA are equal. They are equal to the radius of the circle. The same can be said of triangles BCG prime and ACG prime. They are both isosceles, and sides BC and CG prime and CA are also equal, which means that angles CBG prime and CAG prime, angles CBG prime and CG prime B are both equal, so they are both equal to theta 1, and angles CAG prime and CG prime A are also equal, and they are equal to theta 2. And we also have that ABC, angle ABC equals angle BCA, and we denote those by delta. So we have that beta plus delta plus theta 1 equals alpha plus delta plus theta 2. The deltas cancel out, and we have that beta minus alpha equals theta 2 minus theta 1, or theta 1 minus theta 2 equals alpha minus beta. So there are our two relations. If we add them up, we have 2 theta 1 equals 2 alpha, or theta 1 equals alpha. If we subtract these two, we have 2 theta 2 equals 2 beta, or theta 2 equals beta. Okay, since the angles are equal, the sines are equal, and then we have that A over D equals HC over B equals HB over C, which is what we have here. So that leads us to AB equals HC times D, and AC equals HB times D. We have here that then that B over D equals HC over C over A equals HA over C, which is what we have here. And from this we have that AB equals HC over HC times D, and BC equals HA over D. HA times D. So our three relations are AB equals HC times D, BC equals, or A times B equals HC times D, B times C equals HA times D, and CA or AC, C times A or A times C equals HB times D. So now we have proven that for a circle circumscribed to a triangle, the product of the lengths of any two of the sides of the triangle is equal to the product of the diameter of the circle and the altitude traced to the third side for case 1, the right angle triangle, case 2, the acute angle triangle, and case 3, the obtuse angle triangle. Okay, here we have finished thereby our pre-calculus exercises.